Hello, students of science. In this video, we're going to talk about the gas laws. Let's start by doing a quick review of gas volume and pressure. Remember, pressure is anytime you have a particle inside a container hitting the walls of that container. Now, let's just think that idea here for a moment, and let's say I decrease the volume. If I decrease the volume, if I make it smaller, this means that the particles are going to hit the walls a lot more often. So here I have two containers. One is at low pressure, one is at high pressure. The reason that this one is at higher pressure is because I've made it a smaller space. So I have the same number of particles, but because there's less of a container for them to hit, more or less, they're going to be hitting it more often. So this is going to increase the pressure. So gas volume and pressure are inversely proportional. As the volume is going to increase, the pressure is going to decrease, and vice versa. So when pressure goes up, if I'm going to increase the pressure right here, volume is going to go down. So here I have a container with this set volume. If I increase the pressure, if I squish it down, the volume is going to go down, pressure is going to go up inversely to that. So when volume goes up, pressure goes down, and vice versa. Here I can see I have two containers. The pressure in this first container is going to drop when I open up the stopcock and allow it to go into the other container. I have increased the volume but decreased the pressure because there's more area for them to hit. In this case here, we are not factoring in temperature. This is what is known as Boyle's law. So here I have my combined gas equation. You'll see this a lot more, but I'm not factoring in temperature. Just treat that as a 1 for both of them there. It kind of cancels out. We're just focusing on the pressure and the volume. Now, this kind of leads to a concept called absolute zero. There is no upper limit to temperature. However, there is a lower limit. There is a temperature where you cannot go any lower. So let's take these three different gases. And if I'm continuously cooling off these gases, eventually their pressure is going to be decreasing as well. So here I am cooling down three things. Their volume is getting smaller and smaller, and if I trace it out, it's going to all combine. Now eventually they will start to liquefy when I cool it, but we're going to ignore that. We'll see that these three lines are on trajectory to all meet. If I keep taking this gas and decreasing temperature, the volume decreases as well. And they are all going to converge on a point negative 273 degrees Celsius. Now, I'm going to get into problems here because I'm playing around with negative numbers, and that zero is going to cause a lot of problems. You don't want to use zero in a calculation. Dividing by zero is very bad. So we use a Kelvin scale where you can't actually hit zero. Kelvin is going to be Celsius plus 273.15. For our calculations, you don't need to worry about the 0.15. Just remember it's negative 273. So water normally boils at 100 Celsius. Add 273 to that. The boiling point of water in Kelvin is 373. Water freezes at 0 Celsius. That, of course, is going to be 273. And absolute zero, the temperature at which you cannot get any colder, is 0 Kelvin or negative 273 Celsius. Kelvin is better because we avoid that zero because it's practically impossible to get to absolute zero. You might say it's cool or even the coolest. So again, if I take these three gases and I plot them out, decreasing their volume, eventually they will all combine, they will all converge at negative 273.15. But again, for our purposes here, just round that to 273. That's absolute zero. Now, let's talk about volume and temperature. If you keep the pressure constant, if you increase the temperature, you will have an increase in volume. Here I have two containers. One of them is being heated, one of them is being heated a lot more. The same amount of stuff in there after you heat it up is going to take up a larger volume. Volume varies directly with the temperature in kelvins. Increase the temperature, increase the volume. Decrease temperature, decrease volume. So an increase in temperature means an increase in volume. Here, another two containers here. Once you heat it up, it's going to push up more because it's going to be taking up more space. Pressure is remaining constant. A decrease in temperature means a decrease in volume. If you take a balloon and you put it in boiling water, assuming the balloon doesn't melt or anything like that, it's going to expand. Take that same balloon with the same amount of stuff in there and put it in ice water, and it's going to shrink. The temperature has gone down, which means the volume has gone down as well. This is the idea behind hot air balloons, or a stupid one here with a panda. You heat up the air inside there, it takes up a larger volume. This larger volume means that it's going to be less dense than air, and it's of course going to float. Here's a much, much, much better hot air balloon, Yoda and Darth Vader from Star Wars. So this is assuming we have constant pressure. So in my combined gas law here, I'm not factoring in pressure. I'm just looking at volume and temperature and how they go up together. This is known as Charles' law in some textbooks that you might read. Now let's look at the last part here, gas pressure and temperature. Pressure is the result of gas colliding with a container. Remember, those particles are hitting the sides. A higher temperature gas will hit the container walls harder and increase the pressure. This is the whole idea of what happens with a pressure cooker. It's sealed so nothing can escape. You increase the temperature, the pressure is going to go up drastically. Here, another two containers. This one is heated. These are going to be hitting the walls harder, higher pressure. Pressure varies directly with temperature in Kelvin. Here I have two samples. One of them is in an ice bath, one of them is in boiling water. And this manometer, if you'll remember, that measures the pressure of a sample of gas, is measuring 1 atmosphere for this sample here in an ice bath. Boil it, and it's going to be registering 1.37 atmospheres. Higher pressure because of higher temperature. Increase in pressure, increase in temp. Decrease in temperature, also a corresponding decrease in the pressure. You might see this if you're driving around. The tires on your car, after they heat up, the pressure inside them is going to be increasing. When you're taking the pressure of it, if you do it before driving, that pressure is going to be lower because the tires are a little bit cooler. This is assuming a constant volume. Things are not escaping from your tires or from these sealed samples. So in my combined gas law, volume is not taken into account. This is sometimes known as Gay-Lussac's law. It's French, and obviously I don't speak French. So let's look at those three again. So first one here of my combined gas law, when I don't factor in temperature, that is known as Boyle's law. You'll notice increase of pressure, decrease in volume. So as the volume decreases, pressure is going up. That's the whole idea behind how your lungs breathe. As your diaphragm contracts, it expands your lungs. That doesn't pull air in there. When you increase the volume, that decreases pressure. Lower pressure lungs means the air is going to rush in. So Boyle's law is responsible for, breathing. Charles' law is when I'm not really factoring in the pressure. So now I'm just looking at volume and temperature. When I increase the temperature, I'm going to be increasing the volume. This is the whole idea behind our hot air balloons. Heat up the air, it's going to take up more space, increase in volume. And finally, Gay-Lussac's law does not factor in volume. Now we're just looking at pressure and temperature. Increase the temperature, increase the pressure. Increase the pressure, increase the temperature. Those two are correlated. This is the whole idea behind what happens when you're using a pressure cooker. You increase the temperature inside it, it's also going to increase the pressure as well. So these three, Boyle's, Charles, and Gay-Lussac's, and you don't need to know the names, it's more important that you understand the concept. If you put them together, you get what's known as the combined gas law, which you've seen already multiple times. P1 V1 over T1, P2 V2 over T2. Now, I'm not going to be ignoring any of those because all three of those are very intimately related unless you're deliberately controlling for one. When you use the combined gas law, and we'll be doing a bunch of calculations, and there's another video that will show you how to use some, this will allow you for calculations of temperature, pressure, and volume simultaneously.